Hello students. As we discuss, Rutherford model have some limitation. To overcome the drawbacks of Rutherford model of an atom and to explain the line spectrum of hydrogen, Niels Bohr proposed a model of the atom which was based on the Planck's quantum theory of radiation. So the new model which was proposed by Niels Bohr is called as Bohr's model of atom. Let us discuss Bohr's model of atom. As hydrogen is one of the simplest atom which have only single electron which revolves around the nucleus in a definite path which is called as orbit. Because of this reason, Niels Bohr first explained the structure of an atom, that is for hydrogen atom. Let us discuss what are the postulates of this model. According to this model, hydrogen consists of single electron which revolves around the nucleus in a definite path, which is called as orbits or shells. Orbits are defined as the circular path around the nucleus in which an electron revolves. These orbits are numbered as n equal to 1, n equal to 2, n equal to 3. That means it is numbered as 1 for the orbit which is most nearer to the nucleus, that is this orbit. Then second is given to the next, third is given to the next. Similarly, it is also named as K, L, M, N and so on. So each orbit is associated with definite energy. Therefore, these orbits are also called as energy levels. So according to this theory, each orbit is associated with definite energy. As shown in the figure here, the energy of the first orbit is represented by E1, second is E2, E3, next will be E4, E5, etc. Because of this reason only, orbits are also called as energy levels. Each orbit have definite radius also. And when we count a distance from the center of the nucleus to that particular orbit, we get a length, that is radius. So when we compare the figure in this, you can find that R1 is represented as the radius for the first orbit. R2 is the radius of second orbit. When we count the distance from the center to that orbit, that is the radius for that orbit. Third, for the third orbit, the radius is represented by R3. So for the orbits, there will be a particular radius from the center of the nucleus, which is represented by R1, R2, R3. The energy of the electron does not changes with time. Therefore, the orbits are also called as stationary states. That means, as we know that electrons are revolving around the nucleus in a definite path called as orbits. So when they are revolving around the nucleus, the electron does not loses its energy. That means energy does not changes with time. Because of this reason only, we can say that orbits are also called as energy levels. So from this we can conclude that orbits, which can also be called as shells, it can also be called as energy levels because Each orbits are associated with definite energy. Therefore, it is also called as energy level, and it is also called as stationary states. So whenever we are using a word energy level, it means that it relates to orbits. Whenever we are using the word stationary states, it relates to orbits. So from this, what we have concluded that the orbits or the shells or the energy levels are numbered as n equal to 1, 2, 3, 4 and so on, starting from the nearest of the nucleus, that orbit is 1 and so on. It is also named as K shell, L shell, M shell, N shell and so on. According to this model, only those orbits are permitted in which angular momentum of the electron is a whole number multiple of h by 2 pi. That means the angular momentum of the electron is equal to this relation, that is n into h upon 2 pi, where n is a whole number, m is the mass of electron, v is the velocity of the electron and r is the radius of the orbit, where h is the Planck's constant value. According to this model, the energy is emitted or absorbed only when the electrons jump from one energy level to another. As shown in the figure, two energy levels are represented here, that is N1 and N2. If, for example, our electron is on the N1, that is a K shell, this one, it absorbs a suitable amount of energy, that is E2 minus E1 energy is absorbed and it jumped to higher energy level. The higher energy state of electron is called as excited state. That means when the electron jump from the ground state to excited state, that is from first energy level to the second energy level, it always happens only by absorbing a certain amount of energy, and that energy can be calculated from the formula E2 minus E1, that is the energy of the higher state minus energy of the lower state. This is called as excitation of electron. That means the jumping of electron from the lower energy state to higher energy state is called as excitation of electron, and it takes place by absorbing certain amount of energy which can be calculated by the formula E2 minus E1. Similarly, an electron can jump from higher state to the lower state. That means the electron jump back to the lower energy level, and it takes place by radiating, or we can say emitting, a suitable energy. This amount of energy can be calculated by the formula E2 minus E1. This is called as transition of electron. That means when the electron jump to the higher energy level, it come back to its own ground state by emitting a radiation. This is called as transition of electron. So here energies E1 and E2 are the energies of two energy levels, and the difference in the two energy levels is that energy which is absorbed or emitted when the electron jump from one energy level to another. In other words, we can say the energy of the electron cannot change gradually, but it changes only when the electron jump from one energy level to another. This is explain the fact that atomic spectra are discontinuous. Let us discuss Bohr's theory for hydrogen atom. According to this theory, the energy levels of electron are numbered as 1, 2, 3 and so on. The radius of the orbit can be calculated from the following equation. The equation is Rn equal to n square a naught, where Rn is the radius. Here n represents the orbit. That means if n is equal to 1, that is we are talking about the radius of first. For the radius of second, we'll be taking n equal to 2. For the radius of third orbit, we'll be taking n equal to 3. So what is n here? N is the number which is given to orbits. A naught. A naught is a constant value. Its value is 52.9 pm. That is given as the name Bohr radius. So if we want to find out the radius of first orbit, will be applying this formula. In this, when we keep n is equal to 1, we'll be getting R1 is equal to 1 square into 52.9 pm. So that will be the radius of the first orbit. So in this way, we can calculate the radius of the orbit, which is explained by Bohr. He also explained to find the energy of the orbit, which can be calculated from the formula En is equal to minus RH into 1 by n square, where RH is the Rydberg constant. Its value is 2.18 into 10 raised to power minus 18 joules. Here n is the number of the shell. That is, if we are talking about the energy of first shell, then n is equal to 1. If we are talking about the energy of second, then we have to take n equal to 2. For the third, we take n equal to 3. So if we are finding out the energy of first shell, we have to make the use of this formula. So we'll be getting E1 is equal to minus 2.18 into 10 raised to power minus 18, that is a constant value, into 1 upon 1 square, because n square, here n is equal to 1, so 1 square is 1. That much of joule of energy will be the energy of first orbit. If we are finding out the energy for the second orbit, we have to keep n equal to 2, and when substitute the value, we'll be getting E2 is equal to 2 minus 2.18 into 10 raised to power minus 18 into 1 by 2 square, because here n is equal to 2, so 2 square, and we'll be getting the energy in the terms of joule. So Bohr model has given formula for calculating the radius of the orbit and the formula for calculating the energy of orbit. But Bohr model is also applicable for the ions which containing single electron. For example, helium ion, lithium ion, beryllium ion. All these ions, when you count the number of electron, it all have single electron, just like a hydrogen. So in order to calculate the radius and energy for such type of ions, he has given, or we can say he has modified the formula in this way. So in his formula, he has introduced a term Z, where Z is the atomic number. So the first what formula we have discussed, that is the formula for the hydrogen atom. But for the ions which have single electrons, he has given this formula, that is En is equal to minus RH into Z square by n square. Radius is given by formula Rn is equal to n square by Z A naught, where Z is the atomic number. But Bohr model get failed because there are some limitation in his model. Let us check what are the limitations of Bohr's model. It fails to explain the finer details of atom. This model unable to explain the spectrum of atom other than the hydrogen, because this model was mainly proposed for the hydrogen atom. So it is not able to explain the spectrum of other than the hydrogen. Unable to explain the splitting of spectral lines in the magnetic field, which is called as Zeeman effect. As in the spectral lines, we can find the further splittings when it is in the magnetic field. So such type of explanation is not given by the Bohr's model, therefore it get failed. And even the splitting of spectral lines in the electric field, which is called as Stark effect, it could not explain this effect also. It unable to explain the ability of an atom to form molecules. As we know that atoms combines to form molecule. So this model is not able to explain that why the atoms combine to form molecule. So because of such all limitation of Bohr's model, there is further model was proposed, which will be going to discuss in the next video. Thank you everyone.